In this video, we're going to solve quadratic equations by graphing. Now I have an expression here, y equals x squared plus 5x plus 4, and the parabola is graphed over here. Technically, I have not solved anything. I would need to make my quadratic expression equal to something. Traditionally, when we set y equal to 0, which I've just done here, now we're asking to find the roots of the graph. Sometimes the roots are also known as the zeros. Now remember, I said y is going to equal 0, which means if I was to look where the height of y equals 0, this would be the same as the x-axis. So I guess what I'm really looking for is where the graph crosses the x-axis, known as the x-intercepts. And as you can see where I'm pointing, those 2 points would happen to be the solutions to this graph. So the roots to this problem happen to be at -4, 0 and -1, 0. Now, if I would actually go back to factoring and had gone back and actually factored x squared plus 5x plus 4 and came up with x plus 1 and x plus 4, I would have gone x plus 1 equals 0, I would have subtracted 1 from both sides, and lo and behold, yep, x would equal -1. Over here, I would go x plus 4 equal to 0, subtract 4 from both sides, and yep, x equals -4 was the second root. So this is my first example where I have one of 3 possibilities. And in this case, I have 2 real roots. Now, in this particular instance, the roots happen to be rational because they happen to be falling on exactly integers, -4 and -1. In a future video, I'm going to show you the quadratic formula, and you can tell right here that this discriminant, and this terminology will come up later, is 9. So when I take the square root of 9, it becomes a nice rational number of 3. That's how I know it's going to be rational. Let's tweak this graph so I go down just a little bit farther, and you'll notice now that I have a square root of 5. This means this would be irrational, and you can kind of tell that I am not getting nearly as nice answers in this case, as my roots are not falling nicely between numbers between -3 and -4 and -1 and -2, and I get these unique decimals. So that's a clear sign of this being irrational. Now, I'm doing this in GeoGebra. What you need to be able to do is be able to do the same thing in your graphing calculator. So as you can see, I've gone to x squared plus 5x plus 4. I'm going to go ahead and hit z decimal. You will see that I can see the 2 the 2 roots right here. I just need the coordinates. In this particular case, if I go back to second trace, I will be able to choose 0 as my option. On some calculators, I think I've seen it as roots, but for the most part, it's usually referred to as zeros nowadays. I'm going to go down here. I'm going to hit enter. And for the most part, it's very similar on how to do when we did our mins and maxes. You have to find your cursor, and you have to move your cursor, in this case, far left, okay, left of the root that you're looking for. Hit enter. Move farther to the right, hit enter. As long as this region only has 1 root, there is no reason to guess. And so I'm going to go ahead and hit enter. And you'll see in this case that I got x equal to -4 and y equal to -1e to the -12. What is -1e to the -12? Well, remember, capital E on this calculator is in scientific notation, so that's actually -1 times 10 to the -12. So technically, I'm going to put this down here in the input. If you look down here, that number is coming up as 10 to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. You know what? That's pretty much a 0 to me. So, yep, the coordinates are -4, 0. Well, I'm going to do this again, and I can find the second root by going second trace. I'm going to go over here and hit 0. I'm going to move again a little closer to the second root, which is right there, which I'm going to hit enter. I'm going to move to the right of the root because, again, the region is only covering 1 root. There really is no reason to guess, and so I'm going to go ahead and hit enter. And this time it came up with the exact coordinates -1, 0, so I would say one of my roots is at -1. Now, there's a couple things I want to show you about the graphing calculator. What would have happened if I would have gone 0, move it all the way to the left, hit enter, move it all the way to the right, where I would actually have 2 roots falling within this region. This is where the guess feature comes in. And essentially, if I would put my cursor here, it's probably going to gravitate to the one closest to it, so I would guess that it's going to come back to -1. So I'm going to go ahead and enter. And lo and behold, it did. Now, there is some other little tricks I can show you about when it's setting the left bound and the right bound. So if I go back to 0, you'll notice it says left bound. I can actually manually type in a number. So I can actually go in there. Oops, let me delete that. -4. Come on. There we go. -4.2. Hit enter. And maybe I'm going to go 0.7. I'm going to hit enter. Okay, I went way to the right, but the point is, it's still 2 roots still fall between there and there. I can even guess it. So if I decide, you know what, I think it's around -3. Well, -3 should take me to the -4 root. And in this case, not only does it say -4, but it actually even shows me the proper 0 that I was expecting. So in this case, I'll see that. I think the best choice you can do is highlight or select an interval that only has 1 root in there, and then you don't have to worry about the guessing procedure.